Okay, I'm going to do a couple of elevator problems. Remember, this is where we're in an elevator. So here I've got a 99.8 kilogram superhero. Um, this is Captain America. He's my favorite Avenger, anyway. So he's in an elevator and he is accelerating downward at 5 meters per second per second. And so I want to get his force of gravity and his normal force. Okay. So he's got force of gravity pointing downwards. He's going to have a normal force pointing upwards. And he's accelerating. So we know that means that he has a net force acting on him. So that means these two are not the same. Okay. We don't have any horizontal, any x-axis movement here. So we're just going to think about these two pieces. Okay. So we can go ahead and get his force of gravity. 99.8 times 9.8. That's 978 newtons. That's a lot. Okay. Okay. And then we don't know his normal force, but we know that he's accelerating at 5 meters per second per second. So we can get an F net value using Newton's second law, mass times acceleration. So that's my 99.8 times 5 is my acceleration. $499, I'm just going to round that up to 500 because it's simpler. So that's his net force, okay? And we know that force of gravity, it's always a downward pointing vector. So we know that our F net vector sum, so we remember F net is a vector sum of forces acting on the object. It's also mass times acceleration, and we'll find that we can set those equal to each other in scenarios, and that's helpful to us. So I'm going to set this mass times acceleration equal to normal force minus force of gravity. Okay. And actually, we're accelerating downward. We're in a downward direction. So I really needed to put a negative sign there on that acceleration. So this is going to be, for purposes of the calculation, this is going to be a negative 500. Okay. So I've got negative 500 equals normal minus force of gravity. Normal's pointing up. Force of gravity is pointing down. And I want to solve for normal. So let's kind of rewrite this down here. 5 minus 500 equals Fn minus, I've got 978 is what I had already gotten. And so if I add 978 to both sides, I end up with 978 minus 500 equals 478 newtons for my normal force. So in this scenario, where we're accelerating downward, normal force is going to be less than force of gravity. Okay. Oops, you can't really see that. There. Normal force is less than force of gravity. Okay. Now we're going to do a similar scenario, but we're going to be accelerating upward. Okay. So same thing, same force of gravity because it's the same superhero. So he's 978 newtons. That's just m times g. Again, I'm going to do F net equals mass times acceleration. He's accelerating at 2.5. So 2.5 times 99.8 is going to give me 250. Again, I'm just going to round. So about half of this value, this absolute value, which is same guy, different acceleration. So that tells us how. Reminds us that our acceleration and our FNet are directly related. Okay. And then I'm going to set that again equal to normal minus force of gravity, because even though we're accelerating upward, we're still normal is still a positive direction. Force of gravity is still downward. And that gives me 250 equals Fn minus 978 newtons. And when I add this to both sides, I'm going to end up with 978 plus 250 for my normal force. So that's going to give me 1228 newtons. So here, my normal force is greater than my force of gravity when I'm accelerating upward. And that's why, and we'll talk about this today in class, but that's why when you're moving upwards in an elevator, you feel heavier. You feel like this sensation of being heavier. And you feel lighter when you're accelerating downward. And that has to do with apparent weight, which is actually the same as this normal force. But we'll talk about that more today. So there's two elevator scenarios. And elevators are no movement horizontally. Okay, they're all just vertical. So you'll have a normal and a force of gravity, and they'll either you'll have normal less than force of gravity if you're accelerating upward, downward, or you'll be opposite of that when you're accelerating upward. Normal is going to be greater. Force of gravity always the same. Okay. All right.